Hi, this is Richard C. I'm a math tutor at Wyzant, and I'm answering a question that was submitted by a student. This has to do with exponential decay. In this case, it's radioactive decay. So we have a situation that's calling for us to use this general formula, which I'm going to put up here in red, because I'm hoping that you'll remember to memorize it. And it's this equation, which is exponential decay, where we have an amount at time t. So it might make it easier or it might make it harder. Some people find it harder to think of it this way as a function of t, but this is a good way to think of it. So I'll just write it both ways. So the amount remaining at time t is the principal amount, the starting amount, times 1 minus the rate of decay raised to the t. T is time. So let's go ahead and use this formula. So we're told we want to know how long it will take for Alex to eliminate all this caffeine, 310 milligrams of the caffeine, not all, but half of the caffeine. So we want half is our ending amount. So it's half of that, which is 160. Sorry, half of 310, of course, is not 160. I should just rely on my calculator more often. So that's 155. Go back and fix that. So 155. The reason I made this mistake is I don't actually do this when I'm doing it myself, but when I'm doing for a student, I will plug this in just the way we have it. 1 minus the rate of loss is 0.13, 13%. We just need to solve this for t. The reason I don't use these numbers, I know I'm going to take a half here. I'm going to end up with a half here because I want to find out how long it takes for this ratio, the ending amount divided by the starting amount, to be 1/2. And 1 minus 0.13 is just 0.87 to the t. So simple. We'll take the log, and I'm going to use the common log base 10 here. So I'm going to get the log of 0.5. I'm just going to use decimal here. Is equal to t times the log of 0.87. So on the right, I'm just using law of logs. When I take the log of this entire thing, the t comes out in front, and the log of 0.87 is there. And then from here, we just divide. So t is going to be log of 0.5 over log 0.87. And if you go on your calculator, you'll see that you get 4.98. So it'll be almost 5 hours later when Alex eliminates half the caffeine that his body consumed. And that's all there is to it. So the key to this problem is recognizing, basically, it's a recognition that you have exponential decay here, because every hour it's another 13%, and that 13% is piled on to the previous 13%. It's compounding. And this is very common in biology problems. We'll have exponential growth, or in this case, exponential decay. And so you have to recognize what formula to use. And that's really the hard part. And the rest of it is just plugging in based on the numbers that were presented in the problem. Okay, so it's very nice and simple solution here once you recognize what you need to do. That's it for now. I'll see you again next time. Bye bye.